Hello everyone! In this video, we will review the topics covered in the book Software-Defined Radios for Engineers. By the authors is Travis F. Collins, Robin Getz, Deepen, Alexander M. Wigliski, published in Mobiles Communication Series. Okay, let's start. And um, Contents Preface. Okay. Chapter 1, Introduction to Software Defined Radio, and Brief History. What is Software Defined Radio, or SDR? And Network and SDR. RF Architectures for SDR. Processing architectures for SDR. Software environments for SDR. Additional readings and references. Okay. And chapter 2, Signals and Systems. And we have it to time and frequency domains, Fourier transform, periodic network of the DFT, fast Fourier transform, sampling theory, uniform sampling, frequency domain representations of uniform sampling, Nyquist sampling theorem, Nyquist zones, sample rate conversion, signal representations, frequency conversion, imaginary signals, signal metrics and visualizations, SINAD, ANOB, SNR, T8D, T8D plus N, and SFDR. Aya diagram, receive techniques for SDR, Nyquist zones, fixed point quantizations. Okay. We have to design trade-offs for numbers of bits cost power, and so forth. Sigma delta, analog device, analog digital converters, digital signal processing techniques for SDR, discrete convolution, correlation, Z-transform, digital filtering, transmit techniques for SDR, analog reconstruction filters, DRCs or DECs, digital pulse shaping filters, next pulse shaping theory, two next pulses, chapter summary and references. Okay, let's go. Chapter 3, Probability in Communications, Modeling Discrete Random Events in Communication Systems, Expectations, Binary Communication Channels and Conditional Probability, Modeling Continuous Random Events in Communication Systems, Cumulative Distribution Functions, Time-varying randomness in communication systems, stationary, Gaussian noise channels, Gaussian process, power spectral densities and LTI systems, narrowband noise, application of random variables, indoor channel model, chapter summary, additional readings, and references. Chapter 4, Digital Communications Fundamentals. What is digital transmission? Source encoding, channel encoding, digital modulation, power efficiencies, pulse amplitude modulation, quadrature amplitude modulation, phase shifting K, power efficiency summary, probability of bit error, error bounding, signal space concept, Graham-Schmidt orthogonalization, optimal detection, signal vector framework, decision rules, maximum likelihood detections in an AWGN channel, basic receives realizations, matched filter realization, correlator realizations, chapter summary, additional readings, references. Okay, let's go to chapter 5. Understand SGR hardware, components of a communication system, component of an SGR, AD9363 details, Zinc details, Linux industry input-output details, MATLAB as an IIO client, not just for learning, strategies for development in MATLAB, radio I/O basics, continuous transmit, latency and data delays, receive spectrum, automatic gain control, common issues. Example: loopback with real data, noise figure, references, and Chapter 6: Time synchronization, matched filtering, time error, symbol time compensation, phased lock loops, feedback time correction, alternative error detectors and system requirements, Gardner, Miller and Marler, putting the pieces together, chapter summary, and references. Chapter 7: Carrier synchronizations, carrier offsets, frequency offset compensations, coarse frequency correction, fine frequency correction, performance analysis, error vector magnitude measurements, phase ambiguity, code words, differential encoding, equalizers, chapter summary, references. Chapter 4: Frame synchronization and channel coding, O-frame, where art tall, frame synchronizations, signal detections, alternative sequences, putting the pieces together, field recovery with Pluto SDR, channel coding, repetition coding, interleave encoding, Beer calculator, chapter summary, references. Chapter 9: Chain estimation and equalizations, you shall not multipath, chain estimations, equalizers, nonlinear equalizers, reserved equalization, chapter summary, references. Chapter 10: Orthogonal frequency division multiplexing, rationale for MCM, dispersive channel environments, general of DM model, cyclic extensions, common OFDM, waveform structure, packet detections, CFO estimations, symbol time estimations, equalization, bit and power allocations, putting it all together, chapter summary, references. Chapter 11: Applications for software-defined radio, cognitive radio, bumblebee behavioral model, reinforcement learning, vehicular networking, chapter summary, references. Appendix A: A longer history of communication, history overview, 1750 R 1850 Industrial Revolution, 1858, 1914 Technological Revolution, 1914 6, 8, 190 1916 jet age and space age, 1978, 1979 information age, 1918, 8, 1989 digital revolution, 1998, 1999 age of the public internet, web 1.0, post it 2000, everything comes together. References: Appendix B. Getting started with MATLAB and Simulink. MATLAB introductions, useful MATLAB tools, code analysis and embedded messages, debugger profile, system objections, references. Appendix C. Equalizer derivations, linear equalizers, zero forcing equalizers, decision feedback equalizers. Appendix G. Trigonometric identities, about the authors and index. Okay, thank you for attention and follow we channel for more informations about space, electronic and technology in general. See you.